This is number 27. It says that figure A, B, and C each represent a different set of data collected using surveys. Each set of data represents customer reports on product satisfaction. However, the rating scales and scoring items in each survey were not the same. Which of the following statements is most accurate about the data displayed in the figures? So we're looking for the most accurate, which means like the best answer of all of them. All right, the first one says the variation in terms of range was the same for all three surveys. So let's go ahead and find the range for each survey. Let's start with A. Range is the biggest number minus the smallest number. So 9 minus 3, which is 6. Let's look at it for B. The biggest number here would be 6 minus 0 would be 6. So far, it's the same. And then for C, the biggest number is 6 minus the 1 is 5. Those are not all the same, so probably not going to be A, but we might come back to it if that becomes our best answer, because again, we're looking for the best answer. The measure of central tendency that would be best for all three figures would be the mean. Now, if you're going to use a measure of central tendency, you're going to use either the mean or the median. How you know which one is better depends on whether or not there is an outlier. An outlier is a number that is more like an extreme. It doesn't really fit the data. So let's say that you're collecting a bunch of numbers and most of them lie between the numbers 1 to 10. And all of a sudden you have a random number of like 50. That 50 is an outlier. So let's look to see if we have any random numbers that are really just far away from the rest of the data. From 3 to 9, those are all close together. If we look here, from 0 to 6, everything's been represented fairly well, so it doesn't look like there's an outlier here. And then from here we have 1 to 6. Now that's not a big spread of numbers either, so likely this would not have an outlier either. An outlier would have been something like the number 27. That would have been way off the graph. So, but again, we really wouldn't know unless if we had the original set of data. So based on this, it appears that the mean would be the best form to measure it because we don't seem to have any outliers. So right now, I'm going to put some question marks here to say, hey, is it this one? Or is there a better answer? On C, it says the number of customers who took the survey represented in figure B was equivalent to the number of customers who took the survey in figure C. Now, we can actually count how many customers took the survey, or at least on this response item, by adding up how many of each. So 1 plus 2 plus 4 plus 3 plus 3 plus 1. That would give us a good idea of the number of customers related to this set of data. The issue is that on figure C, each part of this box and whisker plot represents 25% of the data represented. You have no idea whether there were 100 customers that were surveyed here or only 10. This just shows us the data breakdown that 25% of the ratings were between 1 and 3, 25% of the ratings were between 3 and 4. There is no way to know how many customers took figure C without additional information. So therefore, we could not say whether or not these were even equivalent. That is really not a good answer. We're going to go ahead and mark it up because B would have been a better answer choice. On D, it says the interquartile ranges for figures A and C are different. Well, if we're going to do interquartile range, we've actually got to compute that to see if they're different. Starting with this figure A, the idea of the interquartile range is the third quartile minus the first quartile. So it depends on which way you want to go. There's not too many dots, so you could take that stream of numbers and do this. So we have 3 and then 2 4s. Then we have 1, 2, 3, 4 5s, and then we've got 1, 2, 3, 4, 5 6s. And then we have 1, 2, 3, 4, 5, 6 7s here. Then we have just 3 8s and then 2 9s. It's not a terrible amount. You could have actually done this by kind of counting up your dots, but we're going to look for the interquartile range. So the first thing we're going to look for is the median. So you kind of want to take your fingers and work through. These go together, then these go together, and you just go all the way through. So I'm going to work it through here. Looks like this one is my middle number, but just to check it, you want to make sure you have the same amount of numbers on this side as you do this side. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers here. Now notice I kind of crossed out that 6 because that was the median, was this 6 right here. And I like to put a line through it because then when I'm trying to find the first quartile, the line reminds me I don't get to count the 6. So now I'm going to find the median of the lower half in the same way, covering up the 6 and the 3 and working in. It would appear to be this 5, but let's check. That's 1, 2, 3, 4, 5, 6 numbers in, and then 1, 2, 3, 4, 5, 6 numbers in. So the 6 number here is my quartile, my lower quartile. So what I can do then is count here. 1, 2, 3, 4, 5, 6. This is my lower quartile. So here we go, or my upper quartile. We're going to take our upper quartile minus our lower quartile, and our interquartile range for this data set is 2. This is for figure A. Now let's look at our interquartile range here. Fortunately, to find the interquartile range, it's the range of the box. So it's this number 5 minus this number 3 for figure C, which is 2. Those are the same. It says that these are different, but the interquartile ranges here are the same. So this really is not the best answer. That puts the best answer being answer choice B.